So, what I've got is, this isn't quite right because I don't have my laptop in this picture, but I've got two instances of the system in the cloud. One that's running essentially a custom schema, and I also have the ICA schema running there. And in System 2, I've got the Government Record Keeping Metadata Standards schema running and Dublin Core as well. One of the ideas, again, the fundamental ideas that I have is if you think that records are spread across multiple systems and they're all internetworked, then whilst each of them may present a portal into their collection, you should be able to query from a point outside of all of that. So it's a little bit like it's a bit like a web browser hitting different websites. It could be like in the semantic web, a Sparkle client hitting Sparkle endpoints, if that is sort of meaningful. It's like Twitter following a bunch of Twitter publishers. You've got this client that's sitting there getting data from different points in the network and interleaving it somehow. So that's how I've actually built this. So I'll give you a quick demo of some of this. So I've called my project Participatory Record Keeping Infrastructure, or PaRIty, and there's the ability to create schemas or create logical models. So any one of these systems can run multiple schemas simultaneously. So logical models where I create schemas, the ability to actually then create data within a schema, and then this discovery engine that can look at arbitrary endpoints. So we'll go and create a schema. I'll call this a test schema, give it some description. And then within a description we can create various types. And I should say this application is not intended as an end-user records management application. It's a proof of concept for me to test bench all this kind of stuff. So it exposes all sorts of things that would not normally be exposed. So I can create entity types of the main types of my meta model. I'll create a corporeal agent called a person. And this person, by default, gets a name, a description, and a picture in my system. I'll create another attribute, which is perhaps the date of birth, and I'll say it's mandatory. I'll then create another type, and now, because I've already created my person, I can create subtypes of person. So I'll use a really simple example, a student, and if I look at my student, I get the default attributes plus the date of birth as a person, so it's actually handed down from the super type. And for a student, I'll actually create a student ID, for example. So if I've got a person and a student, I'll now create a performance of some sort, a process which I'll call a class. And I can put attributes on the class, but I won't for now. I can visualize that, and I've got a very simple visualization. I'll say a student is a person, and there's this sort of freestanding class object there. I'll just create one more, which is a type of person called a teacher. Okay, and again, if we visualize that, we have a teacher and a student, which is a type of person and a class. If I want to create a relationship, so I'll an allowed relationship, So at the moment, a student can have no relationship, so I'll specify one. And I'll say I want an involvement relationship. So a student is involved in something. And because of the constraints of the metadata schema, the system knows that the only thing a student can be involved in is a performance. And so it enumerates all of the performance types there. Perhaps a little bit clearer is if I were to look at a class and created a relationship and say I want, I'll say involvement again. Then it knows the only things that can be involved in that are students or teachers or persons or a class, because a performance can be involved in another performance. But I'll say a student is involved in a class. I'll create some roles. So I need a learner role. And I'll need a instruction role. And so I'll say a student takes a class, a student in the role of learner takes a class, and a class in the role of instruction is taken by a student. So I now have this student takes a class relationship, and I can actually add attributes onto that. So I could have a let's add. I can make that work. A video of the student taking the class as an attribute. And I can have multiple of those. So if we dash back and have a quick look at the visualization of this schema. A person can be a teacher or a student with is-a relationships, and a student can take a class. All right. So we go look at our domain data now. It tells us that there are these types, and we can create a student item. The attributes are there. And the date of birth, which I said was mandatory. I'll pick one. And a student ID. And I'll create a class, which is F001, which is intro to basket weaving. We can then create a relationship of this class. And you can search for things, and it knows because I've created that allowed relationship type of a student can take a class, this will only show me a list of students. And I can create that. It knows that's the only relationship that's possible between those two types. And I can create attributes on here. And of course there's my video there. I could put a video in, but I won't for now. So we're looking at this stuff. Now, if I look at, there's no records for a person. There are records for a student. I can look at Greg, and there's my details. It understands a relationship, and again, this is quite exposed. There's an involvement relationship. Greg, as a learner, takes a class. I can then follow that relationship into here and look at all of that. So that's pretty straightforward. There's nothing particularly to do with record keeping there. All I've shown you is a system that I can create arbitrary schemas of entities and relationships, but I can show that the relationships are actually constrained according to the model that I had. So I'm going to show you a little scenario. I've picked Robin Hood as an example. So I've got Robin Hood and Maid Marian who were married. There was a wedding and a wedding certificate. I actually found the wedding certificate. Friar Tuck and Little John. Friar Tuck was officiated. Little John and Will Scarlet were witnesses to the wedding. And I've created a purpose-built custom schema to support all of that. I've also got another system that's running a different representation of this. It talks about a guy called Robin Hood spelt differently, with a different description, and a person called Matilda, daughter of Robert Fitzwalter, who was allegedly Maid Marian. I never knew that, but that's who Matilda was. And they got married, and their record is actually a reading of the bands in a particular church. And somewhere else, and that's encoded using Australian Government Record Keeping Metadata Standard schema. So that's mapped into that world with those sorts of entities and those sort of relationships, but backed by the meta schema, my meta schema as well. So I've expressed those things in terms of the AG-RKMS constructs, but it's backed by the interoperable schema. And I've got a simple Dublin core schema of the wedding of Robin Hood with a movie that was actually taken at the time, or a little bit later perhaps. So that's what I'm kind of showing, and what I'm going to do is show some links between those entities in the different system. So what I'm going to show you is that somebody in charge of this schema creates a link into that one, and somebody in charge of this schema creates a link into that one. If we go back to the logical models, so my custom Robin Hood schema has persons, weddings, a person is an agent, a wedding is a kind of an event, and a certificate is a substantial entity type. It's a thing. If you want to have a quick look at the visualization, so we say a person can actually have three roles here. A person can either be a spouse that's wed, can be a celebrant that officiates, or be a witness. They're all enactment relations. And the wedding is represented by this marriage certificate. So we understand that in our terminology, the wedding certificate is a record of that wedding. All right. So if we look at these, I'll look at the persons. So I'll go into domain data. So here are my types, and I've got 5 entries there. I'll look at Robin Hood, and so there's Robin Hood's details, and we can see that Robin Hood as a spouse partakes in this relationship we just saw in the diagram into the wedding. If you look at the wedding, it's got is an enactment. It's got all of these enactment relationships with all these people. It's also got this representation relationship with something. And if I go and look at the wedding certificate, we find the wedding certificate of Robin Hood and Maid Marian. Okay? So we can see that there are these entity types. We can see that there's enactment relationships and representation relationships, and something we call a record. If we go back to Robin Hood, what this enables us to do is actually search for records related to Robin Hood. And we're in a network now, so we can choose how many hops around this network of relationships do we want? How far out do we want to go looking for records? If we choose 0, there's nothing there. If I go back to here, Robin Hood at 0, which is like direct relationship. There's no record there. There's no representation relationship. But if I go one hop further, I can start to see what are things that have a representation relationship. So I can understand what are the things that we may call records. And that can be of arbitrary length. Of course, the further you go, the less relevant the records you find might be. But it means that if you have, for example, a person that's in a role in a agency that belongs to an organisation that was involved in some sort of activity for which there's records, you can actually follow those relationships around and draw the conclusion that those records may have something to do with that person. If you start to get clever and say, well, this person was in this role between these dates, and that role was in this agency, if you sort of date constrain it all, your confidence that record might be relevant might be greater still, if you can actually say all of this. So you can actually start to construct interesting network-based queries based on these relationships that can link people or roles or agencies or whatever to representations that we actually call records. Right? Which I find kind of interesting. If we look at the second system now, this is system 2, and I've given it a kind of a pinky colour. What I've got there is the AGR KMS schema and the Dublin core schema. The RKMS schema is kind of big. You can see that it's got 68 primary entities. And if we actually try and, this is not very meaningful. If you try and visualise this, it's quite complicated. What it turns out to be is that it's quite record centric. There's record, and you can see there's a whole lot of contains, controlled by main document, all that kind of stuff. If we actually look at the data that's inside that particular schema, there's my Robin Hood. And again, spouse in a different sort of wedding. If I look at that wedding, there's Robin, Matilda, and this representation that's the announcement at St Mary's Church. Right? So that's a completely set of documentation to one that's in the other system. The names are different. The entity types are slightly different. The relationships are kind of different. But we do still understand the enactment and the representation of all of this. Because these are conformant systems, so that they're actually running this, behind everything is the same meta model, even though one's in the RKMS and one's in my own custom one. Because they're running the same, backed by the same schema, and because I've constructed this so that they actually share an API that supports that in the same kind of way, we can do things like, let's go back to Robin Hood. I can say that, and I'm doing this as a person in control of this system and this schema here. I can say, I believe that this Robin Hood from over here is the same entity as this Robin Hood over here. So from this schema, I'm pointing out to that schema there. I've decided over here, my documentation of this thing actually documents that as well. So I've dragged and dropped, so I've actually created this link from this system into that system. Bear in mind that over on the left-hand side, the custom schema have not been involved in this. They've created their schema, their records. It's the system over here which has created the link. So if I go in and query through system 2 now and search for my Robin Hood, because I've created that link and everyone's compliant, I get my local set of metadata plus the metadata from the remote site. So all System 1 had to do was agree to conform to the API and conform to expose their information in this sort of semantic web kind of way. And it means now that another system can take that metadata and combine it with themselves. Right? So if I go and query through System 2 now, I get those sets of documentation, and but I still, through System 2, only get my local records. And I can do a similar thing with the Dublin core into the AGKMS, but we're running a little short of time, so I won't do that right now. So that's looking at representations of records within a particular system, being able to follow the chains of relationships around internal to a system, and looking at a portal in one system context, and be able to throw links to external systems and be able to pull in additional sets of documentation from other systems. If we now look at the discovery engine, so this discovery engine is a third place. It's not going in through the portals. It's actually a client that's sitting outside of all of those systems. And a bit like Twitter, we can decide who we're going to follow. Which are the sources of records and metadata we are interested in. So if I say I'm interested in querying the custom schema, it goes out, and because System 1 has this API that's conformant to all of this, it can bring back all that information. So I'm not going through the portal now, I'm going through this sort of just general querying engine. And again, I can look at persons, and I can look at Robinhood, and it looks pretty much the same. And I can pull back, relationships and records and that kind of thing. Where it gets interesting is if I say I want to look at the System 2 as well. So now it's pulled back all of those entity types from the AGKRMS system, as well as those from my custom one as well. And when I search, I search across both of those systems externally. But I only pick up, obviously, things that match the search. So I'm querying from an external place. I've said I want to query both of those systems, and I've searched for Robinhood, which is the term that I know is in System 1. I don't know about Robinhood in System 2. I've searched for Robinhood. But because I'm searching across these systems, and because System 2 points to System 1, I actually pull back both of those. But the interesting thing is that System 1 in this situation doesn't necessarily know about System 2, because the relationship was formed from System 2 into System 1. But the person queried what they thought was System 1 terminology and got the System 2 stuff as well, even though it's called Robinhood and all of that kind of thing. Having queried Robinhood, I now get this relationship that's come out of System 2, and I can follow that relationship and find the records in System 2 that were related to the relationship that was sort of connected because of that one link that somebody said, I think that this in this system is the same as this in this system. And so you can actually follow those links around to find the records. Only, you know the existence of these systems, but all you need to know really is the terminology used in this system. The other thing I should just really briefly mention is that going right back to this model and talking about agency in records, one of the elephants in the room is really access control and authorization. And I haven't really done anything about that other than to say I've created a fairly simple audit trail, and it's so I can say which records have been which. By record now, I mean database record. What things have been imported or edited or deleted or created or whatever. But I built that using this. So I've said there are the substantial entities are database records. Performances are things like create, edit, delete, upload. There are agents that can do stuff. So it can actually be self-hosting. The authorization can be self-hosting. To the extent that you could envisage an environment where I'll use an example again, if you had an indigenous family that had particular controls over particular types of records, if you said that here is a family and here are various activities and here are the records that belong to these activities, you could use the definition of the families and roles to actually control the access to those actual records. If you know what the records are representing in their relationships to the roles, then you can use that record metadata to actually control the access to those records. And then if somebody in charge of that put a different person in a different role in the family at any point in time, then they would get the access to those. So it's bringing the sort of access control regime and the record metadata regime kind of together and being self-hosting, because this schema can support those sort of activities. And again, that's something I haven't really had time to go down in great detail, but I think there's great potential there. Once you start exposing this sort of stuff, it can become simpler to control access to records. If you actually describe who's involved in the records and they have the access in the records, if they need them. And, all of that kind of stuff.